Okay, so good morning, everyone. So last time I, went over syllabus and tried to, look at chapter 1, parts 1 and 2, so that would allow you to work on your homework 1. If you have any questions, let me know. So today I'm going to talk about part 3 of chapter 1, and that's going to help you with homework 2. Now, both homework 1 and 2, they are due by Sunday midnight. And then following that, homework 1 and 2, the quiz is going to be due on Tuesday night. So just follow all the deadlines. So let's get started. So the part 3 module is basically continuation of what we started off last time, that the types of data we talked about. So 2 types of data, quantitative and qualitative. So the qualitative data, so the next level is that what is the level of measurement, right? So once we identify that a data is qualitative or it is quantitative, so the level of measurement, so what you have is that for qualitative variable, we have 2 levels of measurement, nominal and ordinal, right? So nominal level, blood type, so that means it is just categorization of values, so there is no order to it. So blood types can be A, B, O, and AB, A, B, AB, or O. There is no order to it. So you assign that as a nominal level, whereas your grades A, B, C, D, F, so even though it is categorical or a qualitative variable, but these categories, they have order to it, right? So A is better than B, is better than C, is better than D, is better than F. So there is an order to it, and that is why it is going to be at ordinal level of measurement. Right. The one example I talked to you about last time was housing insecurity. And the response to that is that if you're asking this question, whether you encountered or you faced housing insecurity during COVID pandemic, the response would have been either yes or no. So that means these are 2 values for that particular variable. So housing insecurity is a qualitative variable, and the level of measurement is nominal, right? Because yes and no, so we are not looking at any order to it. So this will also fall under nominal level of measurement. Now, similarly, when we look at quantitative variable, so the quantitative variable also has 2 levels of measurement. One is interval, and the second is ratio. Now, 2 important things, and I'm going to explain that with an example. So 2 things which come out from this statement, and one is that for interval, there is no absolute zero. Right? There is no absolute zero. And because of that, you don't have a meaningful, so no meaningful ratio. Whereas for the ratio level, you will have absolute zero. And second, that ratio is going to be meaningful. To explain this, let's see if I can find an empty space. Okay, so let's go all the way down. Okay, so right here. So let's say we have 2 students. One student has ACT score of 20, another one has ACT score of 30. And because these are numerical variables, so we can take the ratio. So ratio is 1.5. The question is that whether this ratio is meaningful or not. And when I say whether it is meaningful or not, basically I'm asking a question that whether a student with ACT score of 30 is 1.5 times smarter than student with ACT score of 20. Right? That's what is being meaningful ratio. Otherwise, it is numerical value. You can always calculate the ratio, which is 1.5, so that's fine. But it has to have some context to it. So the answer to that is that no, that you cannot make a claim that it is 1.5 times, or a student with 30 ACT score is 1.5 times smarter than student with ACT score of 20. And the reason why this is not meaningful is because there is no absolute zero. Now, what does that mean? So that means because we are making a statement in terms of the smartness of student, so there is no ACT score which is going to tell you that student is zero smart. So there is no absolute zero, right? So whether you get score of 10 or 12 or 14, it's not that you are getting a score of 10 that means you are zero smart. So there is nothing like that. And that is what is meant by that no absolute zero. And because there is no absolute zero, the ratio is not going to be meaningful. So that is what is meant by at interval level, where no absolute zero and ratios are meaningful. Now, on the other hand, if you look at distance traveled, so let's say one student travels 100 miles, another student travels 50 miles, and if you calculate the ratio, which is 2, and now you make a statement that student who traveled 100 miles traveled twice as much as the student who traveled 50 miles. So that statement is correct, or that ratio is meaningful. And it is meaningful because there is absolute zero. Because if you travel 0 miles, that means you didn't travel at all. And because we have absolute zero, the ratio is going to be meaningful. So always keep that in mind. So whenever you have to answer this question, that what is the level of measurement, whether it is interval or ratio, this is the question you have to ask, right? And then you decide whether it is interval or ratio. Okay, so let's look at a few examples. So numbers on uniform that identify flares. So that is just an identifier. So that is nominal level of measurement. Student rankings, excellent, good, fair, or poor. So that's categorical, but the level of measurement is ordinal. Temperature on Celsius scale is also interval. Because temperature, remember that whether it is Celsius or Fahrenheit, the ratio is not going to be meaningful because there is no absolute zero. So when we look at the ratios, the ratio which comes out from using Celsius scale is going to be different than the ratio which comes out by using Fahrenheit scale. So we cannot make that claim that today's temperature is 1.5 times warmer than yesterday's temperature. So we cannot make that claim, because if we are changing the scale from Fahrenheit to Celsius, it's going to give you a different ratio. Runners' times in Boston Marathon. So the times are also at ratio level, right? And then calendar years of historic events, that's also interval, right? Because for the calendars also, they don't have absolute zero, right? So different calendars use different starting points. And so that's why the calendar years will also fall under interval level of measurement. So the next step is that once we have the data, right, you want to organize the data, and the qualitative data, or if it is quantitative data, we can use frequency distribution to organize this. So here you can see that we have different categories of faculty, lecturers, assistant professor, associate professor, and full professors. There are 60 of them. And then we categorize them that 15 of them are lecturers, 25 are assistant professors, 5 are associate professors, and 15 are full professors. And then when you draw that, so this is your frequency distribution. Now you can use the raw data also to do that. So if you look at this data, so you have 25 blood types, and if you have to organize that into a frequency distribution, first you have to identify the number of categories, right? So it's blood types. So you have 4 categories: type A, type B, type O, type AB. And then you go one by one, and then you tally that, right? So A is tallied corresponding to A, B is tallied corresponding to B. And these cross, which you are seeing right here, is just to kind of make it a group of 5. Otherwise, just all vertical lines is very hard to count. So this kind of makes it easier that you look at, a bunch of 5s. So you add all of them, and you get the frequencies, and the frequencies must add to the total number of data points. So that means in this particular data, 5 have blood type A, 7 have blood type B, 9 have blood type O, 4 have blood type AB, and the total is 25. And then we can also calculate relative frequency. So the relative frequency is frequency divided by the total, right? So individual frequencies like 5 divided by 25, 7 divided by 25, 9 divided by 25, and 4 divided by 25. And the relative frequencies, they must add to 1, right? Because it's fractional, so it's always going to add 1. Now remember that in the previous one, when we were looking at that as percentage, so you can use percentage also. So the percentage will add to 100%. And when you are using the relative frequency is going to add to 1. Now, if you have a discrete quantitative variable, we can do the frequency distribution table very similar to qualitative data. So here also you first identify that what are the values this data can take. So you can see that it is 0, 1, 2, 3, 4, and 5. Right? So these are the values of the data. There are a total of 50 households. So you tally them. So you will have that number of cars, 0. So there are 4 households with 0 cars, 13 households with 1 car, 22 households with 2 cars, 7 households with 3 cars, 3 households with 4 cars, and 1 household with 5 cars. So that's how you are telling that number of cars. So you are assigning the frequencies, and then the frequencies should add to 50, right? So that is going to give you the total number. And then similarly, you can do the relative frequency by dividing the frequency by the total. So 4 out of 50, 13 out of 50, 22 out of 50, 7 out of 50, 3 out of 50, and 1 out of 50. And then you add all of them, that should always come up with 1. Sometimes you will see that on your Lumen's homework also, that you are going to see that sometimes it is fractional, that it might give you 1.000 something because of that rounding you are doing with the fractions, or sometimes it might just give you 0.99999 depending on how you added the fractions, but it's going to be close to that. And then if you have a data which can take large range of values, right? Because these were discrete variables, but the other thing was that even it was discrete, but it only took in a few values, right? 0, 1, 2, 3, 4, 5. That means there were only 6 possible values for this data. But in reality, you will have a data which will have large number of values. When I say large number of values, not in terms of total number of values, but the values it can actually take. So if you look at this, so even though there are 45 data values, but the range is a lot, that you have so many different values. So what we do is that in that case, we use a grouped frequency distribution. Now, how do we get the group frequency, how we come up with the groups and all of that, that's going to be part of next chapter. But here we just are kind of looking at frequency distributions for different types of data. So we have for qualitative variable, like we saw the blood type example, we have a categorical frequency distribution or qualitative distribution, frequency distribution table. We can have for a discrete quantitative variable, we have that. And then for grouped frequency, we will have something like this, where we come up with classes, so 670 to 679. So all the values which are 670 to 679 and inclusive of 679 are going to be tallied in that class, right? Similarly, 680 to 689, all the way up to 730 to 739. So you can see that 1, 2, 3, 4, 5, 6, and 7 different classes, 45 values. And you can see that there are 2 values in that first class, and an empty class between 680 to 689 means that there is no data value which is in 680s. Right? There are 7 values in 690s. There are 9 values in 700s, 9 values in 710s, 11 values in 720s, 7 values in 730s. So that is, so frequency distribution is like all the same. It is just that what you put in this first column, right? Just to kind of give you an idea that what we just did. So in the first column for categorical frequency, you have the list of all the categories, right? In this case, blood types, A, B, O, and AB. In the discrete case, you have all those individual values which the data can take, in this case, 0, 1, 2, 3, 4, and 5. And then for a grouped frequency, you will have classes in the first column. So that's the only difference. The rest of the columns are pretty much similar, that you tally the data, you have the frequencies, and then you have the relative frequencies. And the relative frequencies are going to be same way, that you look at the ratio of frequency and the total, and the sum of relative frequency must add to 1. Now, the another column which you might see an example or a question on your homework is called cumulative frequency. So the cumulative frequency, as its name suggests, is the cumulative up to that point. So that means for the first class, the value is 2. In the next class, you have 0 values. So that means it still remains 2. How many values less than 699 and less? So that means you add 7 to it, so it becomes 9. So you keep on adding all the preceding frequencies. Up to 709, so you add 9, so that becomes 18. Up to 719, so you add 9 because that's the frequency, so that becomes 27. Up to 729, so you add 11, so that becomes 38. And up to 739, so you add 7, so that makes it 45. So your last cumulative frequency be the same as your total number of data points, right? Because you are adding that up to this point, how many values are there? Up to this point, how many values are there? So the last data point is 739 is the highest value. So all the data values, they have to be less than that. So that is why this number is going to be same as 45. Right? So that's your cumulative frequency. Now the next one is that, so once we have the data, and then we can talk about the studies. So we looked at the sampling methods last time. So here we are going to look at the observational study and an experiment. So first of all, let's observational and experiment. So here the main difference is that if you look at this first example, right? So you have 420,095 people were tracked, and then number of people out of who had brain tumor. So they looked at, and then they came up with the decision. Now here, if you look at that the study, so what this study did was they are simply observing the data. That 420,095 people, they were observed. And from that observation, they came up with this statement, right? So they found no significant difference in the rate of brain tumors between two groups. Cellular telephone was not associated with increased risk for brain tumors, right? Because there was no manipulation, right? That you are not forcing anyone to use cell phones. So it was just natural that people who were using cell phones versus people who were not using cell phones, and he simply looked at the total number of brain tumor or a proportion of brain tumor cases. So this is an observational study. It's an observational study. Now on the second example, right, on this one, so here you can see that you have a group 1, and you have group 2, and then you have group 3, right? So in this case, the rats, they were exposed to different frequencies. So in this case, now you are manipulating the response because you have these groups, and in these groups, you are giving your own treatment. Right? So the different groups are getting different frequencies, and then the results and everything which came up, right? So that's why this is an experiment, right? So you can still compare groups, right? But like in the cell phone use case, then individuals, you are still comparing groups, but you are not influencing the groups, right? Because they were all self-selected, that people are using cell phones, people are not using cell phones. So you had observational study, but with the rats, you are making sure that this group gets this particular frequency, group 2 gets a particular frequency, and group 3 gets a particular frequency. So that's why it's an experiment. Now, the other in terms we are going to use in the next chapters is the response variable and explanatory variables, right? So explanatory variables, so they are also going to be called independent variables. So different textbooks, different papers, you are going to see that independent variable being used. And then similarly for response variable, dependent variable is going to use. So the independent variable is going to affect the dependent variable. So in our example, this brain tumor example, so the response is the incidence of brain tumor, and the independent variable or explanatory variable is the exposure to the different waves, right? So or different radio frequencies. So the different radio frequencies, that's explanatory variable or independent variable, and because of that, there is a response which is the incidence of brain tumor, right? So that's dependent variable. So there's a formal definition. I will let you read that, but the idea is that in experiment we are manipulating the response. That means we are giving treatment to different groups, whereas in observational study we don't give any treatment. It is the self-selected groups, so we just observe what is happening in the groups. Now, the other two terms in this are confounding and lurking variable. So let me try to explain this. So if you look at this study, so let's say we have, or we are trying to study effect of the time of class, right? So time of class. So the time of class is your explanatory variable, right? So that's your explanatory variable. And the response variable, that is, the numerical value or the numerical measure which we are going to actually, compare. So let's say that is the grades, right? So we can compare the grades from morning class and the afternoon class. So that's going to tell us whether it's going to be or which time is better, right? So let's say we have MA155. So we have 8 a.m. section and we have 2:30 section, right? So we have a morning section, we have afternoon section. Morning section is taught by instructor A. Afternoon section is taught by instructor B. And at the end of the semester, and everything else is same syllabus, same notes, same exams, everything is the same exams for both the groups. And at the end of the semester, you compare the grades, right? So that's the study. So you compare the grades. And after comparing the grades, you come up with this response that afternoon class is better, right? Because the grade for afternoon students were better. So now you are saying that afternoon students are better. Now the question now comes that when we are making this claim, look at what is happening here. So when we make this claim, we are saying that afternoon is better. But the question is that afternoon students did better because the class was in the afternoon, or because instructor B was better, right? Because both the sections have different instructors. Instructor A for 8 a.m. class, and then instructor B for the afternoon class. So this is what is called the confounding effect, right? That instructor effect and the time effect, they are confounded. Because the way this study is conducted, we don't know, right, that students did better because of instructor or because of time, right? So that is the confounding effect. So how do we fix it, right? Because there's a confounding effect. That means we have to eliminate, because our goal is to only study the time effect. So that means we have to fix this. And how do we fix this? We fix this by using the same instructor for both the times. That means 8 a.m. section is also taught by instructor A, and afternoon section is also taught by instructor A. The same instructor is teaching both the sections. So now we have made everything uniform. Only difference is the time. So now if there is a change, or if there is that afternoon section is doing better, then you can say that afternoon time is better for student learning, right? So that's the confounding effect. Now the lurking variables, right? So that's another problem which can come. So let's say even if we have fixed this, right? So even if we have fixed this, that the same instructor is teaching both times, and still afternoon comes out to be better, then we have to see that whether there is a lurking variable or not. And what is the lurking variable? The lurking variable is the students in the class, right? Because we didn't make, or we didn't select students in both these groups, right? So it can be, so it will be an observational study, because students just went ahead and registered for 8 a.m. class, students went ahead and registered for 2:30 class. So we didn't have any control over it. So it's an observational study. And in the observational study, it might end up that students who are better are all registered in 2:30, and because they were better, they did well on exams too. So their grades were better. So that's called the lurking variable. So which we are not studying, which we are not incorporating it is, but in the background, it is lurking there, and it is affecting the response variable. So how do we fix this? So we fix this, right? So we fix this by doing an experiment. So how do we do an experiment? That means instead of students, so you randomly assign students to 8 a.m. and 2:30 p.m. Right? So instead of students self-selecting themselves, I can have 50 students registered for MA155, and then I randomly assign 25 to morning class and remaining 25 to the afternoon class. So in that way, I'm going to control the lurking variable, which is the student ability. So this is, one simple way in which, we plan an experiment and do a study where we take care of confounding variable, lurking variables, and if it is possible, we can use experiment and not rely on observational study. One important thing which you should always remember, even after the class is over outside, because in your workplace and when you do or read articles and other things, is that observational studies do not allow you to claim causation, right? So experiments are what we do to claim causation, but not the observational study. So observational study, we are not going to do the claim causation. So that's very, very important. And then the last thing here, so if you have observational studies, they can be of 3 different types: cross-sectional studies, case control, and cohort study. So cross-sectional studies are that at any given point of time. That means if I take a survey today and then report the results, so that's going to be a cross-sectional study. The cohort or case control studies or retrospective studies are that when we, let's say, go to the hospital and then we want to see that what are the factors responsible for stroke, and then we get information from the hospital. So we can have like 100 cases, that means 100 people who are admitted for stroke, and then we can have control, that means 100 patients, let's say, who are admitted for some other reasons other than stroke, right? So we go there and then we look at some parameters like what was the blood pressure, what was, whether they were diabetic or not, what was cholesterol level, those kind of things we measure, and then try to see that is there a difference between these 2 groups, right? So that's called case control or retrospective, where we go back and look into the data in the past. The third type of studies are called the cohort studies. So the cohort studies is that you, like the cell phone example, you saw that you were 420,095 individuals, and then you follow them through the years. So that's, cohort studies are also called prospective studies. So you start with a certain number of individuals and you follow them through. Study could be, a year long, 20 years, you can just keep going. There are studies which have been going for last 30, 40 years. So you follow the individual and then you keep measuring things in that. So that's, prospective or cohort studies. And as you can see some of the examples here, this first one had obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. And then you look at the different measures from those groups. So this is an observational, but it is a case control study. So where we had, children who were evacuated and children who were not evacuated. This one is an experiment, right? Because you have total of 75 given milk with and without xylitol. So you are giving treatment. In this case, that is giving milk with xylitol and without xylitol, and then you are looking at the taste or which flavor was preferred. Now this study, 974 homeless individuals. So this is a cross-sectional study. So at any given point of time, so you are doing a survey with 974 homeless people, and you're asking question about healthcare satisfaction. So this is cross-sectional. And then if you look at this one, so 1.2 million men and women, so they were from 1982, and they are being followed through. So that is again observational study, but it is a cohort study where you are following through the same set of individuals, right? And last thing is that census. So census is when every single individual is talk or information obtained from everyone in the population. And this we already talked about. Any questions? No? Okay, so if no questions, so I think you can either always, go through the notes where, I have my markings on it, or you can just watch these and then also ask me question. I think initially you may not have many questions, but if you start working on your homework problems earlier, then you may have, some, homework questions also, and I will be glad to address those homework questions. So feel free to ask questions either here or office hours or outside of office hours. You can schedule. And as I told you last time, that the link for this Tuesday, Thursday session is different than the link for the office hours. So on Canvas, you can find those links. So office hours or any other meeting you want to schedule will follow the other link. This link is fixed only for these two times at 9 a.m. on Tuesdays and Thursdays. David, Grace, any questions? Anything?
No, I don't have any.
Okay, so if no questions, then I will have this video posted once I get the recording. Have a good rest of the day. Have a good weekend, and I will see you next Tuesday.